In this problem, we want to compute the shaded area here. So we have two squares, A, B, C, D, and E, F, G, H. The side length of the A, B, C, D is A, and it's the same for E, F, G, H. So we have put one of the vertices of square EFGH in the center of the square ABCD, and we want to compute this area, the shaded area here. Okay, so we see that we have to do something here. We can there are many ways to solve this problem, but we can see that we have these two triangles. Okay, or there is another way if we try and rotate this square. Okay, so when we rotate the square, let's assume that we have another square here. Okay, and if we rotate it, we still gonna have this same area here. Why? That's what we have to prove. Okay, so now this area here is always fixed. So if this is A, this is A, this is A, so this is just one quarter of the area of the square. So therefore, the shaded area is A squared over 4. Okay? We can prove it in a similar manner for any type of square that we rotate. Okay, but the key is that if you rotate back this square to make it horizontal, you will see that we will have something like this. Okay, and in this case, since this is the center, we still have A over 2 here and A over 2, and therefore this is a square, and the area is A over 2 times A over 2, which is A squared over 4. Okay, there is another technique that we can use. Okay, we can find the coordinates of these 2 points here. Okay, if I call these 2 points I and J, I can use a rectangular system. Okay, with D as the origin and DC as the x-axis and DA as the y-axis, and I can find the coordinates, and after that I can find the area, the shaded area. Okay, but for me the area doesn't change if I rotate the square bit. Okay, we can prove it using rotation. Okay, here we have 2 rotations. One is centered at the origin by 90 degrees and one is centered at D by 90 degrees. Okay, and once we do that, we still gonna find that the area is A squared over 4. Okay, so if you don't agree, you have to prove that the area is not equal to A squared over 4. Okay, so this is one way. Okay, so we answered the question, what's the shaded area? The shaded area is A squared over 4. Okay, there is another construction that we can do. Okay, so we can link E and G with I and J. Okay, and in this case we get the area as well. But the easiest way is rotate the shape. Okay, so to make it horizontal, and convince yourself that the area doesn't change. It's gonna be the same no matter how you rotate the square. Okay, thank you very much.